deep dive. This time we're looking at safety, real-world safety concerns in the electrical utility world. And we're going to be using a Q&A from the October-November 2024 issue of Incident Prevention magazine as our source material.
Great source.
So imagine you're in charge of safety.
Yeah.
At a utility, you're dealing with aging equipment.
Right.
You're dealing with new regulations. And you have a team that needs answers. So
big challenge.
Big challenge, yeah. So we're going to kind of dive into some of those tricky situations.
Absolutely. Utility safety is a very complex field, and this magazine does a great job of tackling those really practical questions.
Yeah. Let's start with something that I thought was really fascinating, and that is SF6 gas.
Okay.
Which is in tons of high voltage equipment because it's non-flammable and it's great at preventing those arcs.
It is.
But then there's this whole environmental dilemma.
Right. Well, that's the catch with SF6, right? It's incredibly effective for safety and reliability.
Yeah.
But it's also a potent greenhouse gas, much worse than CO2. Oh, wow.
And several states are phasing it out.
Yeah. Which
creates a real headache for utilities who are trying to balance, safety and environmental regulations.
Right.
And then, of course, budgets.
If it's so bad, why are we still using it?
Yeah, phasing out old technology. It's not easy, right? I mean, there's a huge installed base of equipment that relies on SF6. And just replacing it all at once would be incredibly expensive and very disruptive.
Yeah, that makes sense.
Yeah.
So what's the approach then? What would be the best way to approach this? The article had some good advice.
Yeah, so they recommend kind of a three-pronged approach.
Sure.
First, conduct an audit of all your SF6 equipment, just to get a grasp of the age, the condition, potential leak risks. Second, work with the manufacturer's engineer to develop a solid replacement plan. So this might involve phasing out the oldest equipment first, while, maybe exploring newer, more environmentally friendly options.
And then finally, it's just crucial to stay informed about all those regulations, both international, which would be IEC 60376 for handling SF6, and then any state-specific rules.
Oh, right.
That might even be stricter.
Wow. So there's a lot to keep up with.
Yeah, it definitely requires diligence and staying up to date with the latest changes.
Wow. Yeah, it's a whole job in itself, probably.
It is.
Wow. So, all this talk about equipment kind of reminds me of the next question that popped up in this Q&A, which is hotline clamps.
Oh.
Those clamps that you use to open a circuit that's still live.
Right.
And it seems like OSHA is a little vague on whether or not you're even allowed to do that. I don't know. Have you ever encountered that confusion in the field?
Oh, absolutely.
Yeah.
It's a very common point of confusion.
Yeah.
And, OSHA's main concern isn't outright banning the use of hotline clamps, but rather making sure that employees are safe when they use them.
Gotcha.
So if the task can be done safely, with the right tools and the training and the precautions are in place, it might be okay.
Oh, so it's not black and white.
Right. Exactly.
It's about the risks and if it's done by the book.
Yeah. On top of that, most utilities have internal guidelines that are even stricter than OSHA's minimum requirements.
Wow.
Often they're more focused on preventing damage to the equipment, not just worker safety.
That makes sense. Speaking of equipment and safety, this also mentions something called dropouts, which are those non-load brake switches.
Right.
And it said that opening them under load is actually pretty common practice. How does that fit in with all of this emphasis on safety?
Well, think about it. Experienced line workers are using specialized tools, like shotgun sticks, which are designed to provide that distance and insulation. So they're able to open these switches safely, even under load.
So it's having the right equipment and knowing how to use it. But what about situations where maybe remote operation is possible? Would that be considered safer?
Well, there's an OSHA interpretation from 1996 that basically says, look, if you can operate a non-load brake device remotely in a way that completely eliminates the worker's exposure to the hazards, then it might be acceptable.
Oh, that's interesting.
Yeah.
So there's always more to learn about these rules.
Absolutely. And that's why it's so important to stay informed and, consult with experts when you're not sure.
Yeah, absolutely. For sure. Well, I know I've learned a lot even just from this conversation.
Good.
And speaking of things that might cause confusion, let's talk about the insulated elbows on pad mount transformers.
Oh?
Are those things really insulated enough to touch, even with gloves?
That's the question that comes up a lot. And the answer is it's more complicated than you might think.
Okay.
OSHA's definition of insulated depends on the conditions of use.
Okay.
But here's the kicker. Manufacturers often label these elbows as insulated, but their instructions say don't touch, even with gloves.
So why would they even call them insulated if you're not supposed to touch them?
Yeah, it's a gray area where the definitions and real-world concerns clash.
Okay.
Right? You would think if something's labeled as insulated, you should be safe to handle it.
Yeah, with the proper gear. Yeah.
With the proper gear, but the warnings, they suggest otherwise.
What's the right approach? Err on the side of caution.
Absolutely, yeah.
All right.
There was an interpretation by OSHA in 2006 that basically said, look, due to concerns about insulation integrity, potential leaks, and the fact that sometimes drain wires don't function properly, they generally consider these elbows not safe to touch.
Okay.
And they recommend an avoid contact approach.
So even though they're called insulated elbows, treat them as if they're not insulated at all.
Yeah, better to be safe than sorry, especially when you're dealing with electricity.
Yeah, absolutely. That's a great reminder.
Yeah.
I'm sure that resonates with all of our listeners out there. Let's switch gears now and talk about ground testing.
Okay.
Many assume that this has to be done by a certified lab, but the article sets the record straight.
That's a common misconception.
Is it?
Yeah, OSHA doesn't require that you use a certified lab for ground testing.
Okay, so there's some flexibility.
Right.
Okay.
However, they do reference IEA and ASTM standards as great resources for guidance.
Yeah, okay. So companies can make their own procedures as long as they're, within those boundaries.
Correct. So the article outlines two common approaches to ground testing.
Okay.
First, you have your low current ohm testing paired with visual inspection.
Okay.
This is very simple, budget friendly, and it provides a basic pass-fail indication.
So that's good for a quick check.
Right, exactly.
But what if you need a more, in-depth analysis?
Right, then you would want to consider high current testing.
Okay.
This involves running a high current through the grounding cable, which can reveal weaknesses that a low current test might miss.
Okay, and so that's more expensive, I'm assuming?
It can be, but there's a trade-off to consider.
Okay.
Current IE standards actually recommend combining high current testing with infrared scanning.
Oh.
And this helps detect hotspots, which would indicate potential failure points, before they become serious problems.
So it might cost you more upfront, but save you money in the long run.
Exactly. Yeah. Finding that balance between efficiency and ensuring safety.
So it goes back to, again, we talked about the SF6.
Right.
That whole situation, it's like there's always this tension between, doing what's good for the environment and managing costs.
It's a common theme in the industry, and it's why it's so important to have good communication and collaboration between different departments.
That's a good point. That's something for our listeners to think about. How do you balance these priorities? What have you found works?
Well, it's definitely a balancing act, and I think the key is to approach these decisions with a long-term perspective.
Yeah.
Sometimes making that upfront investment in newer, more sustainable technology, it can actually lead to significant cost savings down the road.
That's a good point. It's easy to get caught up in the now and kind of lose the forest for the trees, so to speak.
Exactly.
Speaking of long-term thinking, let's shift gears here to another interesting question from this Q&A. Yeah. It has to do with the location of the ground connection on a structure.
Okay.
Does it really matter where you connect that ground?
You might be surprised to learn that it's not as straightforward as it might seem.
Really?
Yeah, in the past, the thinking was to connect those temporary grounds at the very top of the structure.
Okay.
The idea was that it would create a barrier against backfeed, preventing the voltage from traveling up from the ground.
It was all about the highest point of protection.
Right, exactly.
Yeah.
Okay.
But as our understanding of electrical systems has kind of evolved, we've realized that the location of that ground connection doesn't significantly impact the overall effectiveness.
So connecting it at the bottom is just as good as the top.
That's the consensus now.
Wow.
Supported by research and modeling. And this is actually good news for workers.
Okay.
Because it gives them more flexibility when choosing grounding points. They can prioritize convenience and efficiency without, compromising safety.
That makes sense. It kind of simplifies things.
It does.
Without cutting corners. Yeah, that's interesting how our understanding of these things continues to evolve.
It does.
This actually reminds me of another question
from
this article that I thought was really, really thought-provoking.
Okay.
How much of a role does human error play in safety incidents?
That's a crucial question.
Yeah.
And, it really goes to the heart of how we approach safety culture. In the past.
Yeah. There was this tendency to blame individuals for accidents.
Right.
Focusing on carelessness or failure to follow rules.
Like the blame the worker mentality.
Fortunately, yeah. But thankfully, the industry has moved away from that simplistic view.
Right.
We now recognize that systemic factors often contribute to these incidents.
So you're talking about like organizational culture, communication breakdowns, maybe insufficient training.
All of those things.
Maybe even flaws in the equipment design itself.
Absolutely.
Wow.
These are all factors that can actually set the stage for human error. The article really emphasizes that a truly effective safety approach needs to consider all of these factors. It's about creating this culture of shared responsibility where hazards are identified proactively. Systems are designed to prevent those errors rather than just simply reacting after an incident occurs.
So it's not about letting individuals off the hook.
Right.
But it's about, those errors are often symptoms of something bigger.
Exactly. Imagine a safety net that catches people before they fall rather than punishing them after.
That's a great analogy. Yeah.
Yeah.
So it's about creating that supportive culture.
Right.
And you know what? That idea of a safety net actually reminds me of another question in here. And it's really relevant to, technology these days.
Yeah.
The use of drones.
Okay.
For utility inspections.
Sure.
So drones are becoming increasingly popular.
Yes, they are.
For things like, inspecting power lines, inspecting equipment. They offer incredible benefits like increased efficiency, reduced costs, and they're keeping workers out of potentially dangerous situations. But they come with their own safety considerations.
Absolutely. Yeah, the article points out a few key things to keep in mind.
Okay.
First and foremost, drone pilots need to be properly trained and certified. To operate a drone safely, especially around energized equipment, requires a very specialized skill set.
So you can't just hand someone a drone and say, go check out that tower.
Exactly.
Yeah.
Another big thing is airspace management.
Right.
Utility companies need to coordinate those flights with air traffic control to avoid any collisions with other aircraft, especially in congested airspace.
And weather is a huge factor.
Huge factor. Yeah.
A sudden gust of wind.
Wind, rain, extreme temperatures can impact a drone's stability and performance.
So there's a lot more to it than meets the eye.
Yeah.
It sounds like, a risk assessment before every flight.
Absolutely. A good risk assessment should identify those potential hazards. Evaluate the likelihood, the severity of those hazards. And then implement control measures to mitigate the risks.
So it's a structured approach.
It is.
Okay.
Yeah, and this applies to any organization using drones, not just utilities.
Right. Yeah, it's a good reminder. Let's bring things back down to earth here.
Okay.
Literally. And talk about another question.
For sure.
Which is temporary grounding practices.
Okay.
And particularly the use of cluster bars.
Oh, cluster bars. Those are those handy devices that allow you to connect multiple grounding cables to a single point.
Okay.
And they're essential for establishing an equipotential zone.
Okay.
Basically making sure everything's at the same electrical potential when you're working on those energized lines.
So the question raises a concern about overcrowding on those cluster bars. What's the issue there?
Well, imagine you're trying to plug too many things into one outlet.
Okay, yeah.
You end up with loose connections and, potential problems. Same with cluster bars. If you have too many grounding cables on a single cluster bar, those connections might not be secure, compromising the effectiveness of the ground and putting those workers at risk.
So how do you prevent that?
Well, using appropriately sized cluster bars and following those manufacturers' recommendations for the maximum number of connections.
And then I'd imagine the condition of the cables themselves.
Of course.
All right.
Regular inspection and maintenance of all grounding equipment is critical.
So it's about looking at the whole system.
The whole system.
Okay, speaking of systems, this next question tackles the role of leadership.
Okay.
In safety culture.
Very important.
Within utility organizations.
Yes.
So it's really saying that leadership commitment is essential for building that culture.
It is.
Where safety is actually valued.
Absolutely. It's not just about saying safety is important.
Right.
It's about taking action.
Actions speak louder than words.
Absolutely.
Especially when it comes to,
safety.
Safety.
Yeah.
So leaders have to walk the walk.
They do.
Right.
They need to follow those procedures themselves, actively participate in safety meetings and really foster open communication about hazards and near misses.
So leading by example is really key.
It is.
So everyone feels comfortable speaking up.
Exactly.
Without fear of repercussions.
Yeah, when people feel safe raising those concerns, organizations can identify and address potential problems before they turn into accidents.
That's so important.
It is.
And it also says that effective leadership goes beyond setting expectations.
Yes.
It involves, providing employees with the resources and support they need.
That's right. It's about providing that adequate training, proper equipment, and clear communication channels. It's really about creating this culture where safety is not just a priority, it's just how we do business.
That's great. Now let's get into, a specific aspect of this training.
Okay.
And the article highlights simulators for training line workers.
Sure.
So simulators seem to be becoming really popular.
They are. They're a fantastic tool.
Have you had any experience with them?
Yeah, a little bit.
Yeah.
They provide a safe and controlled environment for line workers to practice their skills and procedures without those risks associated with the live equipment. It's like a flight simulator for line workers where they can experience those realistic scenarios, climbing poles, working on energized lines, responding to emergencies, all in a virtual world.
That sounds incredibly valuable.
It is.
For new workers especially.
Yeah.
Who are still learning.
It allows them to build that muscle memory. And develop their skills in that safe environment.
Yeah.
So, it reduces the chance of errors when they transition to real-world work.
And even for, more seasoned workers.
Right.
Maybe just to refresh their skills.
Yeah, it's like a safety tune-up.
Yeah, exactly.
Keep them sharp, up to date on the latest protocols without,
putting themselves at risk.
Putting themselves at risk, exactly.
Yeah, the article mentions they're particularly good for high-risk or infrequent tasks.
Absolutely.
Something that maybe you don't do all the time.
Right. It's easy for those skills to get rusty.
Right.
Or for complacency to set in.
Yeah.
And simulators are a great way to maintain proficiency.
Okay.
And make sure those workers are prepared to respond if those critical situations arise.
So it's like a bridge between, the classroom training and the real world.
Exactly.
It's a safe space to practice. And, make mistakes, learn from them.
And they allow trainers to introduce challenges.
Oh.
And variables that might not be safe or practical
Right.
to replicate in a live setting.
Right. So you can push the limits.
Yeah. It's that controlled environment.
Yeah, I like it.
Yeah.
So while simulators provide this great opportunity to practice and refine those skills.
Yeah.
The article also talks about, the importance of ongoing refresher training in maintaining that strong safety culture. What are your thoughts?
Refresher training is absolutely essential.
Yeah.
Yeah. I mean, the world of safety is constantly evolving. Regulations change, new technologies emerge.
Right.
Best practices are continuously refined. So refresher training makes sure those workers stay up to date. And, it reinforces those crucial safety concepts.
So it's like a tune-up. Not just for the equipment, but for our knowledge.
To our knowledge, exactly.
Yeah, I like that.
And it helps combat complacency, which, that can be a silent killer.
In any industry.
In any industry, especially this one.
Yeah. It keeps safety top of mind.
Top of mind, exactly.
For the everyday stuff that you might just, become complacent about.
It reinforces the importance of following those procedures every single time.
That's great.
Yeah.
Let's talk about something that often gets overlooked, and that is tools.
Okay.
The tools of the trade.
Right.
The article highlights this.
The importance of proper tool selection and maintenance.
Yeah, this is fundamental.
Good symmetrical work.
Yeah, and, sometimes it's taken for granted.
Right.
But using the right tool for the job and making sure that tool is in good working order can make all the difference.
So it's not just having a toolbox full of tools.
Right.
It's about having the right tools.
The right tools, yeah.
And then making sure they're in good shape.
And they're in good shape.
Yeah.
Yeah. I mean, using a tool that's damaged or worn or the wrong tool for the job can lead to all sorts of problems.
Right. Like what?
Slips, trips, falls, electrical shocks.
Wow.
You name it.
So what should we be looking for when we inspect our tools?
Well, you want to inspect them regularly. Look for any signs of wear and tear, cracks, frayed insulation, loose parts, anything like that.
And follow the manufacturer's recommendations.
Absolutely.
Alignments.
Yes.
Don't try to fix it yourself if you're not qualified.
Leave it to the pros. I could see how that could create more hazards.
Absolutely. forcing a tool to do something it's not designed to do can damage the tool, damage the equipment.
Right.
And really put the worker at risk.
To use the right tool for the job.
The right tool for the job.
And use it the way it was intended to be used.
Absolutely.
So it's about having the right tools, knowing how to use them.
Yes.
And then having a culture where it's taken seriously.
Exactly.
Yeah.
You know, workers should feel comfortable reporting those damaged tools.
Right.
And there should be clear procedures for inspection, maintenance, and replacement.
So this is really highlighting how many elements go into a safe working environment.
It's all interconnected.
Yeah.
Safety isn't just about, following those rules blindly. It's about understanding why.
Yeah.
And applying that knowledge thoughtfully.
I like that.
At every situation.
Speaking of specific situations.
Okay.
This next one focuses on a unique challenge. Working in confined spaces.
Confined spaces. They present their own set of hazards. Yeah. Requiring, specialized training, equipment, procedures.
So it defines a confined space as any enclosed or partially enclosed space that has limited means for entry or exit.
Right.
And is not designed for continuous human occupancy.
That's a good definition.
And it covers a lot, right?
A lot. Manholes, vaults, tanks, silos.
Wow.
Yeah.
And there are a lot of hazards in those spaces.
Absolutely.
It's not just the space itself.
Right. You have atmospheric hazards.
Like what?
Oxygen deficiency, toxic gases, flammable vapors. Then you've got engulfment hazards.
What's that?
Where someone could be buried by loose materials, liquids, even flowing grain.
Oh, good.
And of course, the physical hazards, slippery surfaces, exposed wiring, moving machinery.
So you could have a combination of
correct.
Any of those in the same space.
Yeah, that's why it's so important to conduct that thorough risk assessment before anyone enters.
So identify the hazards, figure out how serious they are.
Yes.
And then what? Come up with a plan.
Develop a safe work plan.
Okay.
Outlining those specific procedures for entering, working in, exiting.
Okay.
And of course, what to do if there's an emergency.
So things like, ventilation.
Ventilation, monitoring the atmosphere. PPE, communication system.
A lot of planning.
A lot of planning, coordination, communication.
Yeah.
There's no room for error.
That's a good way to put it. It's a team effort.
It is.
Yeah.
Creating a system that protects everyone.
This is really giving us a lot to think about.
It is.
It's impressive how much we've covered in this Q&A.
Yeah, it's a testament to those safety professionals and line workers who are really out there working to improve safety in this industry.
All right, so this next one is all about PPE.
Okay.
Personal protective equipment. Specifically, rubber gloves and sleeves.
Right.
And it stresses the importance of verifying the ratings before each use.
Yeah.
I mean, this might seem obvious, but why is that so critical?
It's easy to take PPE for granted, especially when you're using it day in and day out.
Yeah.
But, those gloves and sleeves, they're your first line of defense against electrical shock.
Right.
And that protection only works if they're in good condition and rated for the voltage you're dealing with.
So it's not enough to just grab any pair and assume they'll do the job.
Exactly. I mean, think about it. Rubber can deteriorate over time. Exposure to sunlight, ozone, chemicals, even improper storage can weaken the gloves and sleeves.
Right.
And if there's any damage, even a small crack or puncture, their insulating properties could be compromised.
That's scary. What should you be looking for?
Take a close look at them before each use.
Okay.
Check for any cuts, punctures, cracks, discoloration, anything that seems out of the ordinary. And most importantly, double check that voltage rating printed on the gloves and sleeves.
Okay.
Make sure it matches the work you're doing.
Matching the protection to the hazard.
Exactly.
Yeah, makes sense. All right, let's switch gears now from personal protection to vehicle safety. There was a question about grounding digger derrick trucks. Before starting any work.
Yeah.
Why is that procedure so important?
It's often overlooked.
Yeah.
But it is absolutely crucial.
Okay.
Think about it. These trucks are often used near power lines. Well, and if that truck isn't grounded properly and it becomes energized, it creates deadly hazard for everyone around.
So the ground acts as a safety net, basically.
Exactly. It channels any stray current safely into the earth and away from the truck and those workers.
I see.
Yeah, it creates that low resistance path for the electricity to follow, preventing it from flowing through the truck.
So where do you connect the ground?
Well, it needs to be connected to a designated grounding point.
Okay.
This could be, a system neutral or a ground rod driven into the earth.
Okay.
And of course, you need to use a properly sized grounding cable and clamps that are in good condition.
So no cutting corners.
No cutting corners, that's right.
No room for error when it comes to grounding.
Absolutely. Just like any other safety protocol, grounding deserves your full attention.
Right.
A loose or faulty connection can render the whole system ineffective and put lives at risk.
Let's talk about something that often gets overlooked, and that is static electricity.
Okay.
Which, it doesn't seem as dangerous as a high voltage power line.
You're right.
But this article really emphasizes that it can still pose a significant risk.
It can. It can be that silent threat, especially in environments with flammable materials.
Oh.
It's all about that buildup of electrical charge on a surface. And that charge can discharge suddenly, creating a spark.
And if that's near, vapors or dust,
exactly,
that could be bad.
It could trigger a fire or even an explosion.
So how do you control static?
Well, the key is to kind of combine a few things: grounding, bonding, and humidity control.
Okay.
Grounding provides that escape route for those static charges to flow safely into the earth. Bonding helps equalize that electrical potential between different objects.
I see.
Preventing that sudden discharge.
So no spark.
Right, and then maintaining a certain level of humidity in the air can actually make a big difference in preventing that initial buildup of the static charge.
So it's a multi-pronged approach.
Exactly.
Okay.
It's a great example of how safety often involves addressing those seemingly small hazards that could have major consequences.
It's the little things.
The little things, that's right.
Well, I think we've reached the end of our deep dive.
We have. We've covered a lot of ground.
We have. From SF6 gas to working in confined spaces to everything in between.
Absolutely.
I've learned a lot.
Good.
I'm sure our listeners have too.
I hope so.
It's clear that safety in this industry is a process.
It is.
That requires constant vigilance, continuous improvement.
Yes.
And just a willingness to learn.
Absolutely.
From everything we do.
From our successes and our failures, yeah.
Well, thank you for joining me today. This has been great.
My pleasure.
It's been a really insightful look.
It has.
At electrical utility safety.
It has. And remember, safety is not just a set of rules.
Right.
It's a mindset.
That's a great way to put it.
Keep that in mind.
Yeah.
Stay safe out there.
Anchored in safety. The IP Utility Safety Conference is setting sail to Charleston, South Carolina, from April 29th to May 1st, 2025. Register today at utilitysafetyconference.com.
The views, information, and opinions expressed during this podcast are solely those of the individuals involved and do not necessarily represent those of Utility Business Media and its employees. It is strongly recommended that you discuss any actions or policy changes with your company management prior to implementation.